Angles, Introduction by Abigail Park. Now, for introducing angles, let's try to point out what exactly an angle needs to have in order to be considered an angle. Now, let's start with the basic example right here, which contains two rays that have a common endpoint. As you can see, one ray is called D, one ray is called F, and the common endpoint that the two rays meet at has been labeled E. As you can see, this shows what a single angle looks like. Now let's move on to the vocabulary for angles. The common endpoint that the two rays of an angle meet at is called the vertex. In this case, the vertex is E, which is actually right here. The precise and basic definition of a vertex is the common endpoint of two or more rays or line segments. Yes, there are also line segments instead of just rays, which we'll get to in a minute, but for now, let's keep focusing on the vocabulary. Besides the vertex, as I just mentioned right now, there's also rays, or line segments that are essentially able to create the vertex. Rays are a portion of a line which start at a point and goes off in a particular direction to infinity, while line segments are the part of a line that connect two points. There is a distinct difference between rays and line segments, which is that rays start with an endpoint and go on for infinity. Line segments are a part of a line, which means that they start with an endpoint and end with an endpoint. They are a segment of a line. However, they can both create angles. Now let's look at the definition of an angle itself. An angle is the amount of turn between two lines around their common point, which is called the vertex. Do not mistake the shape two rays or line segments form as an angle, because that is not what an angle is. An angle itself is the amount of turn between the two rays or line segments around their common point, which in this example is E, this area right here. Now let's move on to the key idea of this lesson, which is how to name and label angles. So this will be able to give you a better idea of how to name and label angles. Now there are several angles in this example. So you can see from these two line segments, angles are referred to based on the letters that are designated to a specific line segment or ray and endpoint. For example, right here is angle GHI, which can also be referred to as IHG. The order of the letters does not matter simply because whether you name it this way or that, the measurement of the angle stays the same, as direction or order does not affect that. As long as the vertex, which in this case is actually H, stays in the middle of the two letters that refers to the line segments, then the angle has been named correctly. However, you need a specific symbol to write down before you just write down these letters, as the line segments or the rays need to be identified as a structure that creates an angle. Right here is the angle symbol. We use this to refer to something as an angle. However, even if you have the angle symbol, you still need to be able to specify which angle that you're referring to. So in this example, angle GHI would look like this, and it can also be referred to as angle IHG. Let's see what the rest of the angles in the problem would look like. Angle JHI or angle IHJ. Angle GHK or angle KHG, or angle JHK, which can also be referred to as angle KHJ. Notice that the H is in between all the letters for all the angles, which is able to signify that it's the vertex. The last part of knowing the basics of angles would be learning how angles are generally measured. Some angles are congruent to each other, while other angles are greater than or less than other ones. Although there is much to learn about how to actually find the measure of an angle or solving for one algebraically, it is important to remember one key thing when learning about angles in the beginning. These two angles right here, angle XYZ and angle UVW, can be compared just by how open or closed they are. As you can see, angle XYZ is much more open and angle UVW is much more closed. This shows that the general idea is that when something is more open, then the measure is greater than an angle that would be more closed. You can tell without solving or doing anything mathematically, I guess I should phrase it, that the measure angle XYZ is actually larger than the measure of angle UVW. And so if you are able to compare, you can see that the much more open angle, which in this case is actually angle XYZ, has a greater measure than the more closed angle, which is in this case angle UVW. So that's like the gist or the general idea of what it comes to when measuring angles. So without solving anything mathematically or having to do anything, involving numbers or anything like that, you can just tell, like in a cinch, that this measurement is greater than this one, just based on how open or closed something is. However, there are obviously special cases, such as these drawings right here. The little square by this unknown angle, or not square, I should correct myself, but it's actually like an upside down L right here, uh, actually symbolizes 90 degrees, which is exactly half of 180 degrees, which is actually a straight line. A straight line, speaking of which is right here, looking at this drawing to the right of this one, right here just looks like this. The symbol used for a straight line looks like a semicircle, just like this drawing right here. Various angles can also make up 90 degrees or 180 degrees, which is a more advanced idea that people can learn after mastering the basics of angles. It's called complementary and supplementary angles, which will be learned later in the future. However, this just goes to show how there are special angles that call for special symbols, which must be kept in mind when learning more about these topics. It's just something like a little bit of knowledge that is able to come in handy sometimes. When learning more and delving more into these ideas of using or solving for angles, and these general ideas will be able to help explain more about how to measure an angle and eventually solve to actually find the measure of an angle. Well, this is the conclusion. This is the end. And I hope this video was helpful with learning the basics of angles. And I'll see you next time.